Here are the system routes of a subnet in a network with single VNet. Let's pay attention to the next hop type. When the next hop type is set to none, meaning Azure will drop the traffic. And when the next hop type is internet, meaning Azure will route the traffic to the internet. And when the next hop type is set to virtual network, meaning Azure will route the traffic within the VNet. Now let's pay attention to this route. As you may know, this address space is reserved for the carrier-grade NAT space. So this route is to ensure that all the traffic destined to the carrier-grade NAT space will be dropped. And these routes are to ensure all the traffic destined to the RFC 1918 private ranges will be dropped. This route allows the outbound traffic to the internet, and this route is to enable routing within the VNet. Now, when we create a new VM and attach it to the subnet of the VNet, the VM will use this routing table to route the traffic. Because of this route, the VM can communicate with any VMs in the VNet. And because of this route, the VM can access the internet. And these routes are to ensure that all the traffic destined to these address spaces will never leak to the internet. When opening the effective routes on a NIC card of a VM, you will see the traffic destined to these address spaces are blocked. The first one is the loopback range used internally by the host. The second one is reserved for benchmarking and testing. The third one is reserved for legacy systems or military networks. And the last one is reserved for various Azure services, including front-end endpoints, telemetry, CDN, and service infrastructure. To view the route table associated to a network card of a VM, let's click on the VM, then click on the network settings, then click on the network course. Here we need to click on the effective routes. As you can see, these are the routes